my project-free presentation for the class Data Structure and Algorithms. The group members include myself, Santiago Daza, Aditya Kaushal, and Rushal. And we essentially created a sentiment analyzer which takes tweets or passages and analyzes the different emotions that it portrays. And it's split up into 6 different base emotions, which we'll see shortly. We essentially did this by generating a hash table. Well, 2 hash tables, one using each hashing algorithm that we were utilizing for this project. The hash tables are a set of words. They essentially contain every unique word in our data set with data on how many times they were used and under which emotional tags. And the data itself came from a massive data set which had a whole bunch of different tweets with a whole bunch of different emotions attached. So that's where we extracted the data for our hash tables. And we utilized 2 different hashing algorithms which we wanted to compare, murmur hash and FNV. In general, murmur hash and FNV had very similar collision rates. And murmur hash and FNV also had very similar execution times. Murmur hash, in general, on average, is slightly slower than FNV as it is a more complex algorithm. But due to variance, in this example right here, murmur hash shows up as slightly faster, but they are quite similar in execution time. So yeah, moving on to the actual functionality of our program, you can see here that we're able to insert a passage into the sentiment analyzer. And if we just start off with a very sad passage, you'll see that it displays the different amounts of emotions: anger, fear, joy, love, sadness, and surprise, and the percentages next to them. And there can be a lot of overlap because some tweets can use certain words in a happy sense, in a positive, joyful sense, or in a sad sense. So, for example, the word love could involve heartbreak, so be sad, but also joy because it's joyful, or love because it's directly related to love. So there is a bit of overlap between them, but as you can see here, sadness is the prevailing emotion in that last passage analyzed. And if we just move on to a passage full of love and affection, you'll see that it has a lot of joy, a lot of love, a bit of sadness, but primarily joy and love. Moving on to analyzing just a passage that is overflowing with joy, you'll see that joy is the prevailing emotion with over 53.9%. And then analyzing a very fearful, sort of apprehensive passage, you'll see that fear is the prevailing emotion with 36% there. Then following that, we can analyze a very angry passage and see that anger is the prevailing emotion, or anger is very high percentage-wise with 27% there. And lastly, moving on to a very surprising passage, you'll see that the surprise makes up over 40% of the emotions portrayed in the passage based on the algorithm that we implemented. So following that, we're able to actually analyze individual words. So for example, if I try to analyze a word like love, it'll bring back the percentages that it's associated with the different emotions. So it's associated with sadness, joy, and obviously love to different degrees based on the data set that we analyzed. And we're able to actually analyze the individual emotions to select like up to the 10 words that are most closely related to them. So here's sadness, joy, love, anger, fear, and surprise. And those are the 10 words that are most closely related to those emotions. And that actually depends entirely on the data set. So if the data set were to grow or expand, that would actually grow and expand as well. So that's the emotional analysis. And we're able to actually contribute to the data set ourselves by putting in a passage and selecting what emotion it most conveys, and that actually contributes to the data set itself. So for example, if we had a word that was complete nonsense like norgal, right? Obviously, 0 emotions for all of them because that's not a word, but if we're actually able to interpret it to the data set and say that it's a very loving word, right? And now we're actually able to go to the analysis and see that it has in fact been contributed to the data set and it is 100% associated with love. And that is essentially the base functionality of our program. I hope you enjoyed and have